Okay. Question A. Find the coordinates of A and B. First thing, you all understand the question? Understand? Can straightforward. Okay, coordinates of A and B. A and B both lie on the x-axis. This implies that y equals to 0. Okay. In other words, we are trying to solve negative x squared plus 10x minus 9 equals to 0. So if we want to solve a quadratic equation over here, methods, quadratic formula, factorization, complete square, so on and so forth. Whatever you do, if you want to use factorization, you should end up with x minus 1, x minus 9 equals to 0. Therefore, we get x equals to 1 or 9. Am I right? Any questions so far? Okay, so here A must be 1, 0, B must be 9, 0. Where the method marks? Over here you get M1. This is A1 and this is A1. Okay? Now if you didn't get your M1 mark, even though your answer is correct, you still get 0. Did that happen to anybody? Did that happen to anybody? Didn't show me correct substitution, didn't show me correct factorization, but you use your calculator, get your answer right. Too bad lah, correct answer, but still 0. Okay, mentioned before already. State the line of symmetry. This one. Line of symmetry. Now, knowing that A, this x-intercept is 1 and this x-intercept is 9. 1 and 9. What must be in the middle? This is my line of symmetry. What must this be? 5. Okay, how do we get 5? So line of symmetry, x equals to 9 plus 1 over 2, which is 5. People happily write 5 as the answer and you get 0. Who did that? Who wrote 5 and got a 0? Come on, don't be shy. There are a couple who wrote 5 and got a 0. Who? Don't dare to raise your hand, right? Because you are embarrassed. What? Omar, is it you? 1 mark. That means you wrote the x equals to lah. You know, if you are embarrassed to raise your hand, that means you know that I've already said it so many times and yet you still want to do it. Okay, so this is a B1 mark. B1 mark means I just look at the answer, correct, I give it a mark. Find the maximum height reached by ball. Can you identify where's the maximum point? Very obvious, right? This must be the maximum point. So maximum height will be over here. What is this value? How do I find this value? So x equals to 5, right? X equals to 5, then find the y value. So y equals to negative 5 squared plus 10 times 5 minus 9 and we get 16. Am I right? Okay, so most managed to get it 16 over here. That's a B1 again. Total we've got 5 marks over here. Doesn't really stand for anything. It's just a letter that we used. Okay, now express x squared plus 4x plus 5 in a form. Okay, so this is completing a square question. You done it since Sec 3, right? Done it since Sec 3, and it's only 1 mark. It's only 1 mark. You are expected to be able to do it really easily. So you write x squared plus 4x plus 5 equals to, copy down the first two terms, x squared plus 4x. Now we need to add a certain number divided by 2 and I square it. Then I subtract the same number divided by 2 and I square it again. Okay, and what goes into the numerator over here? 4. Not difficult at all. It is simply the coefficient of x. The first 3 terms gives us the completed square, which is x plus 2 square. Then the next part we've got minus 2 square plus 5, resulting in x plus 2 square plus 1. Okay? Some of you are able to go straight from here to here. Good for you if it is 1 mark. If it is a 2 mark question, you'll be sure to show your answer, your working. So now it is shown in a form. At any point in time, did I say that this is equal to 0? Did I say that it's equal to 0? Is there an invisible equal to 0 here? Have or not? Don't have, right? Don't go and anyhow add it in. Worse, you try and solve it. You try and solve x equals something. Nobody told you that x equals to anything. In fact, this can't even be solved. Okay, now sketch the graph. Labeling the coordinates of the turning point and intercept with any. Okay, my standard format. I like to find my x-intercept. Are there any x-intercepts? X-intercept is when y equals to 0 lah. Okay, when y equals 0, working x plus 2 square plus 1 equals to 0. Right, so we get x plus 2 square equals to negative 1. Possible or not? Possible? X plus 2 square equals to negative 1? Yeah, not possible. So, no solution. So, nil. No x-intercept. It's not going to touch my x-axis. You look at your graph. Did your graph touch your x-axis? If it did, confirm lose mark already. Okay? Y-intercept. That is when x equals to 0. So substituting, I get 5. Alright? Line of symmetry. Line of symmetry is x equals to, what is the line of symmetry? X equals to? Negative 2. How do we get negative 2? If we look at this part lah. Okay? We look at inside the perfect square. We say that from inside this perfect square, I must be able to tell me a certain value of x, which is x equals to negative 2. I want to make it be equal to 0 because that is when my minimum and maximum point happens. Okay, so line of symmetry x equals to negative 2. So what kind of point do I have? Minimum. Okay, minimum point equals to negative 2, comma. And the y value? Substitute in lah. Okay, negative 2, I sub inside here. Negative 2 plus 2, 0. 0 square plus 1, 1. Yeah, you're right, it's 1. You can. You can substitute it into any form of the equation. So now I have a parabola opening upwards. Is it symmetrical? Did I draw it symmetrical? Can, can, right? Oh, you're not happy enough. She's not very nice, So I erase the whole thing. I must show you all that I demand high standards, right? Is that okay or not? Nice enough? No, still not happy. Okay, never mind, I change again. I'm really trying my best. I'm not. This one can or not? Can. Okay, so minimum point negative 2, comma 1. If this is the minimum point, where is my x-axis? Above or below? X-axis is below. Okay. Below or above? How do we decide? We can. Okay, let me show you. Let me show you how to decide. So this line, what is this dotted line? It's line of symmetry, right? And this is the line of x equals to negative 2. So if I draw this dotted line over here, this is actually the line of y equals to 1. Okay, so now it becomes clearer. Where is my x-axis? Above or below? Below. It has to be below. Okay, so maybe something like this. This is my x-axis. Where is my y-axis? Above or below? Oh, sorry, left or right of the line of symmetry? Right side, isn't it? Because this being negative 2, if x equals negative 2 is here, then x equals to negative 1 must be here, x equals to 0 must be here, right? That is my y-axis. And it is supposed to intersect my y-intercept at 5. Right? So wherever my y-axis is, it must cut the graph at y equals to 5. Now since this is 1, this over here is 1, this is 0, 0, 1, 2, 3, 4, 5. So you just roughly see the scale looks fine, then it's okay already. Okay, so this being 5, this is 0, this is y. And then label the graph y equals to x squared plus 4x plus 5. Did I miss anything out? Is this okay? Do you have this graph? Okay, so where do I give it a mark? 1 mark for parabola opening upwards. That's 1 mark. Your parabola wrong place, to the left, to the right, up, down. Nonsense parabola. As long as parabola opening upwards, I give you 1 mark. Next, 1 more mark is for the correct minimum point plus correct y-intercept plus what else? Yeah, I think that's it. Okay? Then that's your 2 marks. But I also minus some people marks. Why I minus mark? You never label your x and y axis. You never label your graph. Or anything that I don't like about a graph, I minus 1 mark. Okay? Questions? Anybody? Any questions? Okay, next, question 3. Solve and represent the solution on the normal line. So we do the left hand side. We got negative 2x less than equal to x plus 3 over 2. And on the other side, so it's actually an n, x plus 3 over 2 less than 5. So solving them separately, we get negative 4x less than equal to x plus 3. Most of you chose to subtract x on both sides, no problem. Negative 5x less than or equal to 3x greater than or equal to negative 3 over 5. Okay, you did the sign flipping. This one, 1 mark. On this side, x plus 3 less than 10. X less than 7. Another mark. That's 2 marks already. Quite good deal, huh? So x is supposed to be greater than or equal to negative 3 over 5. It is supposed to be less than 7. Now, this over here is my final working, my final solution. So I draw one for my own working. This is my x. I've got negative 3 over 5. I've got 7 over here. It is supposed to be greater than or equal to negative 3 over 5. So I draw an arrow this side. It is supposed to be less than or less than 7. I cannot see. Okay, so this is my working. So the region I'm interested in is over here. Okay? If you did it this way, you show me the shading. I can close one eye, I give you 1 mark. But take note, this is just working only. Okay? If you just drew without shading, I'm sorry, it's totally 0. Okay? But I mentioned before, this are working. Our final solution should look like this. And you draw with a ruler. Okay, I didn't do it well. You should draw with a ruler. So this gives you 1 mark. Then when you combine the solutions together, x being in the center, smaller number on the left, larger number on the right, this gives you another 1 mark. Total 4 marks. This one over here, this one is it? I reluctantly gave you 1 mark if you did it this way. Very reluctantly. O level, I don't know how to mark. If you didn't do the working, then it's okay. I'm not giving you mark for that. So you see you have 1, 2, 3, and 4. Let me emphasize. If you did it this way, final answer, I very reluctantly gave you 1 mark. You could have lost this mark. I don't know how the O level marks it. So please don't take the risk. Do it this way. Any questions? What? Oh yeah, I saw this. They're very messy. Right? So I had 3 of them here. Wow, this one I really don't like it. But I close 2 eyes, I give you the marks too. I cancel away for you. Okay? Please listen to what I'm saying. And I hope you have realized that already. I nag and nag, I repeat and I repeat. You know it, you choose not to do it, I penalize you. Okay? So that you will learn, hopefully. I don't know why you want to do that. I really don't understand. Okay, question 4. BCDF. BCDF is a square, straight lines, intersect, blah blah blah. ABG. ABG. This angle is equal to which angle? EDG. Okay? So prove that AGB congruent EGD. I'll draw this triangle out in the same orientation beside it. So AGB went this way. So I'll go this way as well. EGD. Okay. So now I will place all the information that I have in the triangle that I've just drawn. So we saw that, okay, this angle is supposed to be equal to this angle. So GDE, angle GDE is found here. GDE, okay. Isn't it clear that now these 2 angles are the same? I have the same angle already. This is given to me for free. What else do we have? GD, there's a stroke over here. So GD, there's a stroke over here. Oh, how convenient. I gave you another side that is the same. I've got an angle and a side that are the same already. Let me write them down. Angle ABG equals to angle EDG. What is the reason? Given. Yeah, I gave it to you. It is not found, huh? Okay, next. BG equals to DG. Again, given to you. Now I've got an angle, I've got a side. In order to prove that they are congruent, what would you like me to find next? Another angle? Yeah, if I have another angle, then I'll have A as A, isn't it? Which angle do you think is easy for me to find? AGB, this one and this one, right? What is the reason? Vertically opposite. Okay, so let me transfer this angle into my triangle. EGD, EGD, this is the angle. Hey there, look, hey, look, they are the same. I've got side, I've got angle, side, angle. So right now, angle AGB equals to angle EGD. The reason? Vertically opposite angles. So, triangle AGB congruent, triangle EGD. ASA test. Where are the marks? Everything here correct, you get 1 mark. This, you get 1 more mark. Okay? Next, BC equals to ED. BC is equals to ED. Okay, evaluate AB over BC. Interesting question, huh? So right now, AB over BC. Where is my AB? Okay, AB is over here. And BC is over here. How am I supposed to do this? Oh, but take note that they tell me that BC is equal to ED. Okay? What about, now look at this over here. BC equals to ED, right? Yeah, they are different size. I purposely didn't draw it to scale. Okay, yeah, I purposely didn't draw it to scale. Now, since this is a square, then this one also must be the same, right? Right? Then, what else, this one is ED, right? ED is supposed to be the same, right? Where is it on this triangle? It's over here, isn't it? Okay, look carefully, you don't pay attention, you miss it already, So this is ED, and this is the corresponding side to AB. So what is the summary? AB equals to BC equals to BC equals to ED. They're all the same. Cannot. Okay, so this is what I want to find out. AB over BC. And AB is actually the same as ED. Right? AB is the same as ED. Over BC, I don't change. The reason I can say that AB equals to ED, this one you don't need to write out, but AB equals to ED because triangle AGB congruent to triangle EGD. This was found in the previous part. Okay? So since they are the same, what is ED over BC then? ED over BC, come on. They're the same, right? If they are the same thing divided by same thing, of course it's going to be 1. No need. I just want to see the 1. Yeah, I think it was Shufi that you stopped over here. You stop at this side, right? Why don't you want to continue? No, not everybody stop here. Most people didn't get this. You also stop there. Okay, name a triangle that is congruent to ADC. ADC, then it must be triangle E, B, and C. Yes? Cannot. I already say the name matters. So over here we got a total of 4 marks. Okay, next page. Prove that the 2 triangles are congruent. So I'll draw it over here. So EBC. Okay, come, prove that these two are the same. What do we already know? BC. BC is the side of square, right? Yeah, so it must be the same lah. Okay, then this is an angle in a square, angle C. ECB. ECB. This must be 90 degrees also. In fact, it is a common angle. Okay, I've got a side, I've got an angle. What do you want to find next? There's so many things you can do. How about I find EC? Can I prove that EC is equals to AC? How? EC and AC. Yes! The two triangles are congruent in the previous part. Okay, so I'll just do the working over here for C part 2. For C part 2, BC equals to DC. Properties of square. Okay, then we got ECB. Angle ECB equals to ACD. This one also, this is common angle. Okay, not so much about properties of square, but it is the same angle. Next part, I want to prove that EC equals to AC. So this one, alright. EC is broken down into ED plus DC. Over here, ED equals to AB. Okay, so ED and AB, they are the same. AB corresponding sides of corresponding triangles. Then we've got BC is equal to DC lah. Okay, these two combine together to give me EC equals to ED plus DC, which is the same as AB plus BC. So this gives me AC. Corresponding sides of corresponding triangle. Okay, so now I've proven that I've got a side, I've got angle, I've got side. Yeah, so triangle ABC corresponding to triangle EBC SAS. Okay, so all these 1 mark, this one also 1 mark, 2 marks. RHS possible if you do it correctly. Then too bad lah.
So if I were to put the reasoning as corresponding, then
Yes. Okay, 1 more minute. Question 5. Prove that two triangles are similar. Okay, BAF and EDF. I'll draw it in the same orientation, but this time it is smaller. EDF is smaller. So this being BAF, this must be EDF. Okay, now let us draw in all the angles that are the same. Very clearly, we got vertically opposite angles, right? Okay, so this one, EFD, this must be the angle. We've got so many other angles we can try. For example, let's use this. ABF must be the same as DEF over here. 2 angles already. So, working, angle ABF equals to DEF. Reason? Alternate angles. Parallel lines? Need to write parallel lines or not?
Yes.
Don't write how?
Minus.
Minus mark, and I did minus. Parallel lines. Oh, did I minus? Oh, you wrote corresponding. No, of course minus lah. Wrong reason what? Next, angle AFB equals to angle, so this one over here, the double stroke, DFE. Vertically opposite Angles. These two, 1 mark. Since 3 pairs of angles, blah blah blah, triangle, blah blah blah, similar to triangle, blah blah blah, 1 mark.
Yay.
Full marks. Anybody? Nobody.